All right, everyone, it has been 2 minutes, so let's take a look at that little half sheet you picked up on the way in. Again, the intent of this is to help you identify numbers from problems so you can put in the appropriate column in your list of variables. So, and again, vertical component of velocity, horizontal component of velocity. I took that wording straight out of Engelmann-Krauss. So if it's a vertical component of velocity, now and some of you are still confusing vertical and horizontal. Vertical is in the Y, horizontal is in the X. The horizon, right, the sun comes up over the horizon, okay, that's in the X direction. Okay, so when we talk about vertical component of velocity, and I put starts with to hopefully prompt you to say initial, so it's VIY, vertical Y initial. We measure all velocities in meters per second. Time is the variable t measured in seconds. Displacement is delta x. Oh, I'm sorry, displacement in the x direction is your delta x. That'd be like how far does it land away? That's that kind of question. That's measured in meters. Acceleration in the y direction is AY, which we measure in meters per second squared. And chances are really good if it's a projectile motion problem. Well, chances are really good it's going to be a projectile motion problem. So if it's a projectile motion problem, one of your like if-thens is if it's projectile motion problem, then your AY is negative G, which is negative 9.8 meters per second. So not only for this, like 99% of the time is that meters per second is negative 9.8 meters per second squared. Displacement in the y direction, delta y, which is measured in meters. Final velocity in the x direction is VFX, which is measured in meters per second. Again, all velocities are measured in meters per second. And the last is horizontal component of velocity. So horizontal x component of velocity, VIX. And that's measured in meters per second. That's the intent of that. There are 5 problems on that practice. It's called practice quiz 1. There's only one practice quiz, but practice quiz 1. There are 5 calculations, 3 of which are horizontal launch, 2 of which are angle launch. On Monday or Tuesday, the 23rd, 24th, we have a physics test. There's 2 parts to this physics test on 2D motion. Part 1 is a concept question test. 15 multiple choice questions. I think it's 15, maybe it's 17. 20, 15, I think it's 15, I'm sorry, I think it's 15 though. Multiple choice questions, and there's 5 calculations. Chances are pretty good. 3 of them are going to be horizontal, and 2 of them are going to be angled. Very similar to the practice test. What is it you have in practice? Now, one of the things people struggle with is pacing on tests like this. There's 5 calculation problems. Once I stop talking, you have some time. Kind of keep an eye on how long it takes you to do these 5 problems. Because in addition to doing 5 calculation problems on Monday or Tuesday, you have to answer 15 multiple choice questions as well. And if you don't finish in the 53 minutes, then we can hang out a little bit longer on Monday or Tuesday. Monday for you guys. And we can finish. Because I want you to finish. I don't want you coming back tomorrow or the next day or in a week. You start the test, you're going to finish the test. So pacing is going to be important. How do you get better? You practice, you practice, you practice, you practice. So I have answers posted. I have half the front side on one table, the other half on the other table. I don't even know which one's which. I worked through the problems. I tried to highlight things, you know, like, hey, the time is here because I used time in 3 different spots. This is the same kind of time. It all came from this calculation, okay? So I tried to do some highlighting on the answer key. Problem number 5, I fixed from last hour, but there's 2 solutions if you do quadratic. If you do the quadratic formula for question number 5, there's 2 solutions, just like there is for any quadratic. The problems we did in class yesterday, 2 days ago, they had a negative solution as one of the other things because we started here, we ended low, where the other solution was before my stopwatch started. In this particular problem, it starts low and it ends high. There are 2 different locations that have the height of 1.5 meters. There are some context clues that should help you figure out which of your 2 times you want to use. If you get stuck, let me know. But I think it's worded such that you should be able to figure those out. There is a Socrative review posted. T. Davies 2D is the room name, is posted in Canvas as an assignment. It's 41 questions, it's kind of long, but the intent of it is not only to help review for the multiple choice portion, but it's also to help you identify problem types. And then from problem types, what can you pull from that information? Oh, it's a 2D motion problem, then we make two lists of it. This projectile motion problem, AX is 0, AY is negative 9.8 meters per second squared. Things like that. Those are all things off that yellow problem type sheet. I will give you a copy of that on the test. I will give you a copy of that equation sheet. On these 5 practice quiz, on these 5 questions on the practice quiz, I would encourage, you should have that out. Unless you have that memorized, you should have that out and be using that as a reference. I will give you that reference on next week's test. During this time, if you have questions, please ask. Please, please, please ask. Make sure you're asking those questions. If you know you're going to be gone, it'd be great if you make some arrangements so we can take this ahead of time instead of afterwards. So let me know what I can do to help. I'm here. Answers are posted in 2 different tables. I did have some students choose to work together, and I'm okay with that. We just got to make sure we're kitty corner. So in the event that Mr. Rather says, hey, was so-and-so within 6 feet for 15 minutes, I can say, no, they were sitting kitty corner from one another. That is over 6 feet, Mr. Rather. We do not have to contact trace anyone. I'm okay with that if we work together. But just remember, it's easy when we work together. Say, hey, what's the answer to number 5? 6. Okay, sure, it's 6. I have no idea why it's 6, but I have 6. I got it done. So just be careful.